Good day, viewers. You are welcome to today's math class. So let's solve this interesting integral question. So let's start now. Firstly, we'll be using partial decomposition. So we can rewrite this. Wait, we have the integral of 1 over x raised to the power of 4 plus 1. And this is equal to the integral of 1 over. When you factor this, we can rewrite this by saying into bracket x squared plus root 2x plus 1, and here we have x squared minus root 2x plus 1 also dx. Don't forget the dx sign. Now, don't forget I said we are using partial decomposition method. So when we are to solve the partial fraction, we are going to have 1 over x raised to the power of 2 plus root 2x plus 1 into bracket another x raised to the power of 2 minus root 2x plus 1 into bracket. This is equals to, so we have ax plus b over x squared plus root 2x plus 1 into bracket, and we have plus cs plus d into bracket x squared minus root 2x plus 1. Now let's cross multiply it. Therefore we are going to have 1 is equals to ax plus b into bracket multiplied by x squared minus root 2x plus 1. So we are also going to have x plus d into bracket multiplied by x squared plus root 2x plus 1. Now we have here, when you open the bracket here, we are going to have, so we are going to have, when you open this bracket, we are going to have ax raised to the power of 3 minus a root 2 x squared, and we are going to have ax. So multiply this by b also, we are going to have plus bx squared, we are going to have minus root 2 bx, and we are going to have plus b. So for the second one, we are going to have plus cs raised to the power of 3, we are going to have plus cs squared root 2cs squared, and we are going to have cx. And for d, when you multiply through by d, we are going to have dx squared, we are going to have plus root 2 dx, and we are also going to have plus d. So now we are going to factor out the coefficient. Let's start with those that have x raised to the power of 3. For those that have x raised to the power of 3, we have a plus c is equals to 0. For those that have x raised to the power of 2, which is this, so I'm taking it out. So we have, here we have c, here we have b, here we have d, and here we have minus a. Don't forget the number sign. Here we have root. So here don't forget the root 2. So we have root 2a, all equals to 0. Now let's compare the one with only x. Because I'm shading it. So we have a. Starting with a, we have minus root 2b. Next we have plus c. We have plus root 2d. That's all. So also equals to 0. Now the last one is b and d. So b plus d, we are comparing it with 1, is equals to 1. Now let's solve for a, b, c, d. Starting with this is equation 1, equation 2, equation 3, equation 4. If you look at the equation 2, we have b plus d. And in equation 4, we said b plus d is equals to 1. So substitute that into equation 2. So we are going to have root 2c plus 1 minus root 2e is equals to 0. So now take this, we have root 2c minus root 2a is equals to minus 1. Now don't forget from equation 1 we said a plus c is equals to 0. So c plus a is equals to 0. Now let's multiply all through by root 2 here. When you multiply all through by root 2, you are going to have root 2c minus root 2a is equals to minus 1. Here we are going to have root 2c plus root 2a. Root 2 times 0 is going to give us 0. Now add the two equations together. This is going to cancel out each other. When you add this together, it's going to give us 2 root 2c. And here when you add this together, we have minus 1. So therefore, if you divide by 2 root 2, our answer for c is minus 1 over 2 root 2. So this is the value for c. And when this is c is equal to this, don't forget we said c plus a is equal to 0 from equation 1. So a is equal to 0 minus c. A is equal to minus open bracket minus 1 over 2 root 2. Therefore a is equals to 1 over 2 root 2. We have gotten the value for a and c. Now let's look for the value for b and d. Now, if you look at equation 3, no, if you look at equation 3 now, we said b plus d is equals to 1. And sorry, we are looking at equation 2, a plus c is equals to 0. Now, so we have in equation 3, we said a plus c is equals to 0. So when you substitute that there, we are left with 0 minus 2 root b plus root 2d is equals to 0. So we have root 2d minus root 2b is equals to 0. This is for equation 3. And don't forget, b plus d is equals to 1. So we have d plus b is equals to 1. Now I want to let the coefficient here to be the same. So let's multiply through by root 2, the way we did here. So we have in this equation now we have root 2d minus root 2b is equals to 0. And here we're going to have root 2d plus root 2b is equals to root 2. So let's add the two equations together. When you add the two equations together, the addition for this is 2 root 2d. And here this is going to cancel out each other. And here we'll be left with root 2. So divide all 2 by 2 root 2. When you divide all 2 by 2 root 2, d is equals to, this cancels, we have root 2 over 2 root 2. So let's move to this. So we can even see that root 2 cancel out each other, therefore d is equals to 1 over 2. You get d is equals to 1 over 2. So now, don't forget b plus d. So don't forget here, we said b is equals to 1. So we have b is equals to 1 minus d. And b is equals to 1 minus 1 over 2. So b is equals to 1 over 2. So I've gotten our values for the equation now. Let's now substitute. We said the integer of 1, okay, the integer of 1 over x to the power of 4 plus 1 is equals to the integer. We said as plus b. So where is our a? We have 1 over 2 root 2 s plus b. Where is b? B is 1 over 2. All divided by bracket s squared plus root 2x plus 1. And here we have plus two brackets. We have cx. C is equals to minus 1 over 2 root 2 x plus, where's our d? D is 1 over 2 divided by s to the power of 2 minus root 2s plus 1. Now, this place is very tricky, but we're going to solve. Let's start with this first. Firstly, let's multiply the numerator and denominator by 4 root 2. So we are multiplying by 4 root 2, the numerator and denominator of the equation. Now, if you multiply 1 over 2 root 2 by 4 root 2, this is going to give us, this is equals to 2x, and here if you multiply it by 4 root 2, you are going to have plus 2 root 2x. All divided by, here now will be, it will be 1 multiplied by 4 root 2, 1 over 4 root 2 rather, multiplied by s is the power of 2 plus root 2x plus 1 into bracket. And here we are going to have plus, no? So let's change the sign here. When you have negative here, this positive sign is going to change to negative. So we are going to have 1 over 2 root 2x. Don't forget, here is going to change to, here is going to change from positive to negative. So we're going to have minus 1 over root 2. Reason why minus times this is going to go to minus 1 over 2 root 2. And here, minus times this minus sign is going to go to plus. Don't forget. Now we have x squared minus root 2x plus 1. So, here now also we are going to multiply the numerator and denominator by 4 root 2. But we are going to do that for now. Here now, we can rewrite this by saying 1 over 4 root 2, the integer of 2x plus root 2x plus root 2 rather, sorry, I made mistake writing this x, plus root 2 over x squared plus root 2x plus 1 plus root 2 over x squared plus root 2s plus 1. So now, how did I get this? Don't forget, I rewrite this. We have 2s plus 2 root 2 here. So root 2 plus this root 2 is going to give us 2s plus root 2. So I separated it. I separated the terms. And here now, when you multiply the numerator and denominator by 1 over 4 root 2, we are going to have minus 1 over 4 root 2 here. And here we are going to have 4 root 2. We are going to have 2x. And here we are going to 4 root 2. In 4, that's 2 root 2. It's the same with this. It's only that the sign changes. Here we have negative, here we have positive. So we have x squared minus root 2x plus 1. So now, here now, we say that the derivative of the denominator here will give us the value for the numerator. Don't forget, the derivative of this is equal to this. So we can just say that this is equal to 1 over 4 root 2. Here now, the integral of this is going to give us the ln of x squared plus root 2x plus 1. And here now, we are going to have root 1 over, here now, we can rewrite this in a form by writing it as in this form, a raised to the power of 2 plus b raised to the power of 2. We can rewrite this in this form. That is going to be s plus 1 over root 2 raised to the power of 2 plus 1 over root 2 all raised to the power of 2. So here now, this is 1 over 4 root 2 s 2s minus 2 root 2, and here we have s squared minus root 2s plus 1. So here now, I open to the next page. We are here. So we have 1 over 4 root 2. Here the ln of s squared plus root 2x plus 1. Plus, here now, let's recall the trigonometry substitution. When you have something like this, when you have 1 over s squared plus a squared, this is equals to 1 over a into bracket tan inverse x over a. So when you have something like this in this form, we're going to be using this substitution. So we have root 2 into bracket, we have 1 over a, here will be 1 over root 2. We have tan inverse, we have x, which is s plus 1 over root 2, all divided by 1 over root 2. So here now we have minus 1. Now I want us to do something. Let's say that 1 over 4 root 2 and all this is equals to k. So let's represent this with k because it is too large and there's no space here. So let this to be equals to k. We are still going to move to that later. Let's solve this first. So here now we are going to have 1 over 4 root 2 into bracket the ln of s squared plus root 2x plus 1. And here we have, so you solving this is going to give us root 2. So root 2 multiplied by root 2, we have 2 tan inverse of, here now we are going to have root 2x plus 1. So we have solved for this side now. Let's now move to this side. Don't forget, we said k is equals to minus 1 over 4 root 2. The integral of, don't forget, we are still coming back. We have 2x minus. So here now we have over s squared minus root 2x plus 1. So the way we solve the first one, we are going to have minus 1 over 4 root 2. So the integral of 2x minus root 2. Don't forget we separated the terms in the first one too. It will be inside brackets. So we are going to have minus. The reason why you have minus sign because of this negative sign. Root 2 over s squared minus root 2s plus 1. So now we have minus 1 over 4 root 2. Don't forget the derivative of this denominator is equal to the numerator. So it will be ln of s squared minus root 2x plus 1. And here now you have minus root 2, the integral of 1 over, you can rewrite this by saying x minus 1 over root 2 all raised to the power of 2 plus 1 over root 2 all raised to the power of 2. So we'll be using the property here, don't forget. So we have minus 1 over 4 root 2 into bracket the natural log of s squared minus root 2x plus 1. And here we have minus root 2. So here we are going to have x 1 over 1 root 2. And we have tan inverse is equals to multiplied by x. Here these are x minus 1 over root 2 all divided by 1 over root 2. So now let's Don't forget we have to open this bracket. This is going to give us minus 1 over 4 root 2, the natural log of x squared minus root 2x plus 1. So here now, when you solve for this is going to give us 2. So minus 1 over 4 root 2 multiplied by 2 is going to give us minus 1 over 2 root 2. So we are having tan inverse, and here we have x minus 1. No, root 2x minus 1. So we have solved for this finish. Let's now join it with the first one. Don't forget here, we haven't opened the bracket, so we are going to open the bracket and join it with this. Now, in the first one, we said when you open the bracket, we are going to multiply it by 1 over 4 root 2. So we have 1 over 4 root 2, the natural log of x squared plus root 2x plus 1 plus here 1 over 4 root 2 multiplied by 2 is going to give us 1 over 2 root 2. We have tan inverse of root 2x plus 1. So let's join it with this. So I've gotten the value of k. So we have minus 1 over 4 root 2 multiplied by the natural log of x squared minus root 2x plus 1 plus 1. Here now we have minus 1 over 2 root 2 tan inverse root 2x minus 1. Now if you look at this, these are like terms, and don't forget recalling the property of logarithm, natural log. When you have the natural log of a minus the natural log of b, this is equals to the natural log of a divided by b. So you can just say, don't forget they have common term here. Let's factor it out. So we have 1 over 4 root 2 and the natural log of x squared plus root 2x plus 1 all divided by here now we have x squared minus root 2x plus 1 into bracket. And let's look at this also. Here what we can factor out here is 1 over. Now don't forget here now we have, so let's factor it out. We have 1 over 2 root 2 into bracket. It will be tan inverse of this, which is root 2x plus 1 into bracket. Here now we have minus, so it will be minus tan inverse of root 2x minus 1. So all this is inside bracket. So this is our final answer for this exciting maths question. Guys, please don't forget to like, share and subscribe. Thank you.